Hello everyone, myself Professor Hemantazanpure from Kekewag Institute of Engineering Education and Research, Nashik, from Applied Science and Mathematics Department. Today, I am going to take the lecture on complex integration. For that, some points we require to find the value of complex function, to find the value of the integration whenever we are having the complex function. So first one is the singular point. Let us understand the meaning of singular point. The point z0 is said to be the singular point of the function f of z if f of z is fails to be analytic. Analytic means not defined at z0. Such a points are called as singular point. For example, you can see here f of z is equals to 1 upon z minus 2 into z minus 5. Then for z equal to 2, denominator is getting 0, means function is not defined. 1 upon 0, that is infinity. And for z equal to 5 also, the denominator is getting 0. This implies goes to that z equal to 2 and z equal to 5 are the singular point of f of z. Now let us start with the Cauchy's integral theorem. If f of z is analytic on and within the closed curve C, then integration of f of z dz over that curve C is equal to 0. Means there is no any singular point which lies inside the curve C. In that case only directly you can write the value of that integral f of z dz equal to 0. Means when the function is analytic on and within the closed curve C. Now, next is the Cauchy's integral formula. If f of z is analytic on and within closed curve C except at point A which lies inside the curve C, then in that case f raised to n of A is equal to n factorial upon 2 pi I integration over the curve C of f of z upon z minus A bracket raised to n plus 1 dz. Means we are going to use the integral formula whenever we are having the point which lies inside the curve C. Whenever we are having the point which lies inside the curve C, in that case we use the Cauchy's integral formula, where that f raised to n of A denotes the derivative at the point A. Now let us start with the examples. See, in this example, we have to evaluate integration over the curve C of z square plus 1 upon z minus 2 dz, where in the first part of the example, the curve is the circle modulus of z minus 2 equal to 1. And in the second part of the example, that curve is modulus of z equals to 1. So let us denote the given integral by I. The very first step of the example, denote the given integral by I, which is equal to integration of z square plus 1 upon z minus 2 dz. Now identify the singular point of the function f of z. Z equal to 2 is the singular point because you can see here for z equal to 2 denominator is getting 0. So as denominator is getting 0 means function will be infinity, that is fails to define. So that's why z equal to 2 is the singular point of the function f of z. So it is the first step of the example, that is we have to identify here the value of singular point. Now curve. In the first part of the example, the curve is the circle modulus of z minus 2 equal to 1. Now check whether that point z equal to 2 lies inside or outside the curve C. For that, let us substitute that point in the left hand side of the equation. left hand side of the equation, that is z minus 2. Z is 2, so 2 minus 2 will be 0, and that is less than the right hand side. If it is the case, if that value of the left hand side is less than the right hand side, this implies goes to that point lies inside the curve C. Now just check here how that point means geometrically, how that point lies inside or outside the curve C, that we are going to see here. You can see that since modulus of z minus 2 equal to 1, this equation, what this represent? This represent the circle. Just put z as a x plus iy, so it will be modulus of x plus iy minus 2 equal to 1. Just collect the real part in one bracket and plus the imaginary part. So it is equal to, by applying the modulus definition, modulus of x plus iy, that is equal to under root of x square plus y square. So it is under root of x minus 2 square plus y square equal to 1. Squaring on both the sides of the equation, you will get this is the circle with center at 2 0 and radius equals to 1. Means you can see this is the circle having the center at 2 comma 0 and radius 1, and just by observation you can see the point 2, 2 0 is the center. That means obviously the point 2 lies inside the curve, inside the circle. Okay, so in solving the example we are not going to do this procedure, which I have written in red. We are just going to do this procedure, just put that value in the left hand side and check whether it is less than or greater than the right hand side. So once you get the point which lies inside the curve C, inside whatever point is there which lies inside the curve C, that point we denote by A. Now we have to choose the function f of z which will be defined on that curve C. Now we have seen that if I take as it is function and put over this circle, then you will not able to get the analytic function. As it is function is not analytic, right? Because of which term? Because of the denominator term. Because of denominator term, the function fails to define. So that's why neglect the denominator term and take the remaining part of the function as f of z. And now you can see here, this is the function. It will be analytic, means it is defined on that curve. Means for each point the function is defined. Once you get a and f of z, then write the Cauchy's integral formula. F raised to n of a equal to n factorial upon 2 pi I integration over the curve C of f of z upon z minus a bracket raised to n plus 1 dz. Now choose the suitable value of n as a 0 here, because see the example. In this example, to the denominator we required z minus 2 bracket raised to the power 1. So you should have the value of n as a 0, then only you will able to get the required function f of z of the given integral. That's why the suitable value of n as a 0. So let us substitute that value here. It will be f raised to 0 of 2, it is equals to, it is f raised to 0 of 2 equal to 0 factorial upon 2 pi I integration over the curve C of z square plus 1 upon z minus 2 bracket raised to 0 plus 1 dz. So therefore f of 2, here substitute the value of a. F of 0 means no derivative. No derivative means only f of 2 equals to 1 upon 2 pi I integration over the curve C of it is z square plus 1 upon z minus 2 dz. Now since f of z is equal to z square plus 1, so replace z by 2, you will get f of 2. So that f of 2 will be equals to 5. Now substitute that value of f of 2 here, 5. So 5 equal to 1 upon 2 pi I integration of z square plus 1 upon z minus 2 dz. And now just shift that 2 pi I to the another side. You will get the answer as 10 pi I. So this complete the answer of the first part. Now in the second part of the example, they have given the curve is nothing but the circle. Another curve is there. Function is same. Your function is same, just the curve is different. Curve is the circle. Modulus of z equal to 1. Modulus of z, that is modulus of x plus iy, which is equals to under root of x square plus y square equal to 1. Now again check whether that point lies inside or outside. Now you can see mod of 2. Just put the value of z here in the left hand side of the equation of the curve. Mod of 2, that is 2, which is greater than 1. So if it is greater than, this implies goes to what? Whenever the point that left hand side is greater than the right hand side, then this implies goes to the point lies outside the curve C. You can see that geometrically also. Modulus of x plus iy, that is nothing but x square plus y square equal to 1. This is the circle having center at 0 0, radius 1, and you can see the point 2. 2 is the point which lies outside the curve C. So z equal to 2 is lies outside, means this implies goes to, if we take as it is function f of z equal to z square plus 1 upon z minus 2, then that function will be analytic on and within the closed curve C. And therefore, if it is the case, if you are not having any singular point which lies inside the curve C, in that case, by Cauchy integral theorem, the value of integration f of z dz over the curve C equals to 0 by using the Cauchy's integral theorem. Now, let us move towards the next example. In this example, we have to evaluate integration over the curve C of 4z square plus z upon z minus 1 bracket square dz, where that curve C is the circle. Modulus of z minus 1 equal to 2. So let us denote this integral by I. This integral by I. Again, the very first step of the example, that is, you should write singular point. Singular point is z equal to 1, means it is the point for which the function becomes infinity. Now let us check whether that point lies outside or inside the curve C. For that, in the left hand side of the equation of the curve, put that value of z equal to 1. So left hand side 1 minus 1, that is equals to 0. And as it is strictly less than the right hand side, means this implies goes to z equal to 1 lies inside the curve C. So whatever point is there which lies inside the curve C, that we denote by A. So therefore A equals to 1. Now again in the similar way, if I consider the as it is function, it is not defined on the curve because of the point z equal to 1. Because of the point z equal to 1 means because of that denominator term. Right? So neglect that denominator term z minus 1 bracket square we are going to neglect, and the remaining part of the function will consider as a f of z. And once you get a and f of z, then by Cauchy's integral formula, f raised to n of a equal to n factorial upon 2 pi I integration over the curve C of f of z upon z minus a bracket raised to n plus 1 dz. Now again here about the suitable value of n. For that, you see this denominator term, we require z minus 1 bracket square. So when you put here n as a 1, then only you will get z minus 1 bracket square, which is the required term because it is the given integral. So that's why the suitable value of n will be 1. That's why it is the f dash. F raised to n that represent the derivative, that is it is the f dash of 1 equal to 1 factorial upon 2 pi I integration over the curve C of 4z square plus z upon z minus 1 bracket square dz. Now let us find the value of f dash of 1. Since your f of z is 4z square plus z, differentiate it means you will get f dash of z, which is equal to 8z plus 1, and then you replace z by 1 means you will get f dash of 1. F dash of 1 equal to 9, and then substitute here in the left hand side. F dash of 1 is 9, so it is equals to that 9 is equals to 1 upon 2 pi I integration over the curve C of 4z square plus z upon z minus 1 bracket square dz. Just shift this 2 pi I to the another side, you will get it is as a 18 pi I. So it is the answer of the integral 4z square plus z upon z minus 2 bracket square. Now let us start with the next example. Evaluate. Again we are going to evaluate here the complex integration. It is the function is sine square z upon z minus pi by 6 bracket cube dz, where that curve C is modulus of z equal to 1. So since again you denote this integral by I equals to integration of sine square z upon z minus pi by 6 bracket cube. Now the singular point is here z equal to pi by 6, because when you put z equal to pi by 6, denominator is getting 0, so it is the singular point. Now the curve is modulus of z equal to 1. Modulus of z, that is modulus of pi by 6, that is 3.14 upon 6, and it is obviously less than 1. So whenever it is less than 1, this implies goes to what? The point lies inside the curve C. And as the point lies inside the curve C, let us denote that point by A. And your f of z is sine square z. Now, once you get A and f of z, then by Cauchy's integral formula, f raised to n of A is equals to n factorial upon 2 pi I integration over the closed curve C of f of z upon z minus A bracket raised to the power n plus 1 dz. Now, again we have to choose here the suitable value of n. So the suitable value of n will be 2, because again you see the power of this denominator term, that bracket raised to the power 3 is there. So that's why we are going to substitute here the value of n as a 2. N as a 2 means you will get here f raised to 2 of pi by 6. F raised to 2, that is f double dash of pi by 6, and the right hand side is 2 factorial upon 2 pi I sine square z upon 2 z minus pi by 6 bracket cube dz. Now here f raised to 2 means f double dash of pi by 6 we have to find. So let us see how to find out that f double dash of pi by 6. For that you can see here f of z is there, which is sine square z. F dash of z, just take its derivative. Its derivative f dash of z is 2 sine z into cos z. So f dash of z is sine 2z, and f double dash of z is 2 cos 2z. And now you replace z by pi by 6. So right hand side will be 2 cos 2 into pi by 6, means it is 2 cos pi by 3, and the value of cos pi by 3 is 1 by 2, means the value of f double dash of pi by 6 is equals to 1. So substitute that value in the equation. You will get 1 equal to 1 upon pi I integration of sine square z upon z minus pi by 6 bracket cube dz. And now just shift this pi I to the another side. You will get the value of the required answer, the value of the given integral. So it is the answer of example number 3. Now let us have some more example on the same, that is Cauchy's integral. Next example, that is evaluate. In this example again we have to evaluate integration over the curve C of z square plus cos square z upon z minus pi by 4 bracket square dz, where curve is modulus of z equals to 1. So since here z equal to pi by 4 is the singular point, now again check whether that point lies inside or outside. So modulus of z means modulus of pi by 4, and it is obviously less than 1, means this implies goes to that z equal to pi by 4 lies inside the curve C. So here a equal to pi by 4. Whatever point is there which lies inside the curve C, that is we denoted by a. So here a equals to pi by 4 and f of z is equal to z square plus cos square z, means we'll have to neglect here again the denominator term. Now by Cauchy's integral formula, f raised to n of a equal to n factorial upon 2 pi I integration of, I have substituted here the value of f of z dz. Now again the suitable value of n is here 1 because we required bracket raised to the power 2 to the denominator. Z minus pi by 4, its power should be 2. Now to calculate f dash of pi by 4, since your f of z is z square plus cos square z, let us differentiate it. So on differentiating you will get 2z minus sine 2z, and now you replace z by pi by 4. So you will get 2 into pi by 4 minus sine 2 into pi by 4, that is pi by 2 minus 1. So substitute here the value of f dash of pi by 4, which is pi by 2 minus 1, and it is right hand side is 1 upon 2 pi I, and in the next step of the example you just shift 2 pi I to the another side. You will get the answer. Now the next example, evaluate integration of 2z square plus z plus 5 upon z minus 3 by 2 bracket square dz, where curve is the ellipse x square upon 4 plus y square upon 9 equals to 1. Now here the singular point is z equal to 3. 3 by 2 is the singular point. Now the equation of curve is not given in terms of z. As the equation is given in terms of x and y, so we'll write the singular point also. This is the singular point. We are going to write in terms of x and y. Means just write here z as a x plus iy. Then on comparing the real and the imaginary part, you will get x equal to 3 by 2, y equals to 0. Now see the curve. Curve is x square upon 4 plus y square upon 9 equals to 1. Now in the left hand side of the curve, you substitute the value of x and the value of y. So see, when we substitute here x as a 3 by 2, see here I have substituted the value, and y as a 0, it is 9 by 16. 9 by 16 which is less than 1. So whenever it is the case, then the point z equal to 3 by 2 lies inside the curve C. And now, therefore, by Cauchy's integral, whatever point is there which lies inside the curve C, that we denote by A, and the function, whatever the remaining function is there, just neglect that denominator term. Whatever remaining function is there, that is your f of z, and which will be analytic on and within the closed curve C. Again you write here the same Cauchy integral formula statement. In these you substitute all the values, the value of A. Again the suitable value of n will be 1, means it is f dash of 3 by 2. You are having f of z, take its derivative, that is f dash of z, and then you replace z by 3 by 2. So we will get f dash of 3 by 2 equal to 7. And now just substitute that value here in the equation. You will get 7 equal to 1 upon 2 pi I integration of that required function, that is 2z square plus z plus 5 upon z minus 3 by 2 bracket square. So its answer is 14 pi I. Now the next example. See, in this example we have to evaluate integration of z plus 4 upon z square plus 2z plus 5 dz, where curve is the circle, modulus of z minus 2I equal to 3 by 2. Now the very first step, you should write the denominator in factor form. Just find the factors. You will get the factors as minus 1 plus minus 2I, and hence the factor form of the equation will be z plus 1 minus 2I and z plus 1 plus 2I. Okay, so see, I have denoted the given integral by I, and write the denominator in the factor form. Now you can see the singular points here, z equal to minus 1 plus 2I and minus 1 minus 2I are the singular point. Now just check here whether this point lies inside or outside the curve. Put the first point minus 1 plus 2I, so the value will be 1 and it is strictly less than 3 by 2. This implies goes to that point lies inside the curve C. However, when we put the second point z equal to minus 1 minus 2I, you can see here its value is root of 17, and which will be greater than 3 by 2. This implies goes to the point z equal to minus 1 minus 2I lies outside the curve C. So here whatever point is there which lies inside the curve C, that is the point A, and the function which will be analytic, that is z plus 4 upon z plus 1 plus 2I. Now you write the Cauchy integral formula. In that, put the value of A. Again the suitable value of n will be 0. Then calculate f of minus 1 plus 2I, and which will be 3 plus 2I upon 4I. Substitute that in the equation. So we will get 3 plus 2I upon 4I into that 2 pi I, which will be the answer of the given integration of z plus 4 upon the required integral to the denominator. I have just written the factor form, but that is nothing but what the required integral denominator term is z square plus 2z plus 5. So you can simplify the answer. After the simplification, see these 2 2's are 4. I will also get cancel, and you can write the final answer as, that is pi into 3 plus 2I upon 2. So that is the value of the complex integration. So this is all about the topic complex integration. Thank you.